In past paper questions, this is from past paper question, they might be asking us this kind of question as well, that why cracking is useful. Why cracking is useful. So I have already told you that in the process of cracking, what happens, we are basically converting the long chain hydrocarbons are converted into small chain hydrocarbon. And what I was telling before, these long chain hydrocarbons, they are less useful. They are less useful. And these small chain hydrocarbons, they are more useful. Are you getting my point? So they are more useful. Like, for example, we can say this is long chain hydrocarbon. And we can even take this example like kerosene. Kerosene, has not much use, but in fact small chain hydrocarbon, which can be a petrol, which has more uses. Okay, so in this way this long chain hydrocarbon can be converted into small chain hydrocarbon by the process of cracking. Okay, and so we can even describe this
Okay.
thing as well, like long chain hydrocarbons which are less useful, for example, kerosene, that could be converted into more useful small chain hydrocarbon, that is petrol. बेटे बात समझ आ गई है आपको?
Yes.
अच्छा. So let's move further and now let's uh, come towards a very important reaction for alkane, that is free radical substitution reaction. This question has a lot of importance, a lot of importance. They are oftenly asked in the exam. Okay. So please be focused during what I'm going to explain you right now. So now, free radical substitution reaction, for example, we have this ethane. This is ethane. Okay. So this ethane basically reacts with this chlorine. Chlorine is halogen. So it is reacting with this halogen under the presence of UV light. बेटे ये बात बहुत इंपॉर्टेंट है that this reaction occurs under the presence of UV light. And if we are not giving it any light, what happens? The reaction would not take place. Is that clear? So now, what happens
Yes.
here? One chlorine from this side is going to replace this hydrogen, and this hydrogen would react with another chlorine. So the reaction would become like this. So one chlorine would come at this point, and the hydrogen from this would react with another chlorine, and that would be HCl. Is that clear, beta? So this is the reaction that has been going to take
Yes.
place. Now, I'm going to describe you about the mechanism. This is very important. Mechanism of free radical substitution reaction. For example, like what happens in this reaction? First of all, there is a reaction which is called as initiation. Initiation. In this initiation reaction, what happens? We know that this chlorine is having a double bond. Okay, like this kind of double bond is with this chlorine. And now what happens when we are giving it UV light? UV light, then what happens? They are going to split up into radicals. Into radicals. What are radicals? First of all, what are radicals? Radicals are the atom with unpaired electron. With unpaired electron. So this is what we mean by a radical. What happens here? We know that chlorine is having, I'm just going to describe it to you. The chlorine is having 7 electrons in its outermost shell like this. So there is an other chlorine which is having
Just
7 electrons like this, and they are making a bond like this. Okay. So what happens? We are giving it UV light. Okay. Why we are giving it UV light? So that this bond will be broken. So that bond will break. Okay. Bond will break. And we know bond breaking is endothermic reaction in which heat energy is absorbed. So what happens? This bond will be broken and this one electron will go towards this chlorine and the other electron would go towards this chlorine. Is that clear, beta? So this is basically called as radicals. They are called as radicals which have unpaired electron. I hope this point is clear.
yeah. Do I need to know this that from here these bonds will go to here?
Yes, you must know it, but for
Okay.
exam purpose, what you need to know this thing. Need to know this thing that this reaction occurs under the presence of UV light, and you must know this thing that under the presence of UV light, these free radicals would form. Is that clear, Sultan?
Yes.
Now, what happens? Now, one more important thing that you must need to know. This bond breaking is basically called as fission. We call this as fission. Now, there are two type of fission. There are two type of fission. The one is homolytic fission and the other one is heterolytic fission. Is that clear, Sultan? So one
Yeah.
homolytic fission is the fission that occurs here. This is homolytic fission. Now I'm going to tell you the difference between them. This is homolytic fission and why we are calling it as homolytic fission. So what happens in homolytic fission? So you can take the example, like for example, this is H2 and when the bond will break, it would form these free radicals. So what happens in homolytic fission? Two same radicals would be forming, which are carrying each electron. Okay. So two radicals are formed in it. Radicals are formed and having same number of electron, same number of, you can say, unpaired electron. Like we can take the example of, you can say, chlorine as well. Like it is forming Cl dot plus Cl dot, this free radical. We can take the example of bromine as well. Okay, they are taking one electron like this. But what happens in heterolytic fission? Now look at this. Like for example, we have HCl. Okay, we know that they are basically having, they have shared each electron from both of the sides. Now, what happens that as we know that chlorine being more electronegative, so it is more electronegative. So what we mean by this thing that it is basically pulling this paired of electron towards itself, towards itself. So when the now it would be carrying this negative charge, partial negative charge, as it is pulling the electron more towards itself, and this would be carrying partial positive charge. But what happens when this bond would break? Then due to hydrolytic fission, then what happens? Hydrogen would be carrying H positive charge, and chlorine would be carrying this negative charge. So now you have seen one thing, that with the bond breaking, these electron would go on the chlorine side. Are you getting my point? So hydrogen is not having any
Yeah.
electron with itself. Is that clear? So this kind of fission is basically
Yeah.
called as heterolytic fission. This type of fission is called as heterolytic fission. So now if we go up, like in this free radical substitution reaction, what happens? Homolytic fission actually take place. Okay? So now,
Okay.
yes, अब आपको clear होगी है what you mean by heterolytic fission and homolytic fission?
Yes, I understand homolytic fission fully, but
Hmm.
I'm still slightly confused
Okay.
on the
Heterolytic.
heterolytic fission.
Okay, now this point, I hope so, is clear that they are basically sharing a pair of electron, but due to more electronegativity, you know, I'm sorry. Do you know what is basically electronegativity? Electronegativity is basically the force of attraction with which basically an atom attracts the shared pair of electron more towards itself. Okay, so that is basically electronegativity, and we know that chlorine is having more electronegativity than hydrogen, so it is basically pulling this shared pair of electron more towards itself. And because of that, what happens? Partial negative charge would comes on chlorine, and partial positive charge would come on hydrogen. Is that clear? So
Yes.
now what happens when this bond will break? Hydrogen would not be having any electron with itself. Now it has become an ion, and chlorine, as it has pulled this electron more towards itself and the bond has broken, so it is having a negative charge like this. So this kind of bond breaking is basically called as heterolytic fission, when where the shared pair of electron has been pulled by one atom and the bond has been broken. Okay?
Okay. But are they still radicals or no?
No, they are not radical now. They have become
Okay.
ion. Okay? So now let's move further and let's discuss some other part of it. Now, first part that we have done, that is initiation reaction. And now let's move further towards propagation reaction. So first of all, the most important thing that you must know in propagation reaction is this formula. The formula is that there is a free radical which is going to have a reaction with a normal molecule. And what happens? They'll be forming a normal molecule. They are going to form a normal molecule and a free radical. Oh, so they are going to form a normal free radical like this. Now what happens? This free radical is going to form this normal molecule, and this normal molecule is going to form this free radical. How it is going to happen? Let me show you. Like for example, first of all, we have a free radical which has been formed, that is Cl dot, and it is going to react with this ethane molecule, that is H dash C, H, H dash C, H, H, and there is H here. So what happens now? As this radical comes near to this place, so there is a bond here which is going to be broken. This bond is going to break, and this hydrogen, okay, we know they have shared an electron pair with itself. So this hydrogen would break, and this is going to make a bond with this chlorine. Is that clear? And when it is going to make a bond like
Yeah.
this, so it is going to form HCl like this. Plus, now there is only this electron which is present on it, so it has become a radical. It would become a radical like this, and this carbon, there is hydrogen here, and this hydrogen here. So you have seen one thing, that this radical is basically, now let me just show it with some, yes. Now this radical is basically forming this normal molecule like this, and this normal molecule has going to form a radical like this. Sultan, is that clear?
Um, so I'm slightly confused.
Okay. Okay, let me just explain it one more time. Maybe it would be clear. So, what happens, this hydrogen and this carbon, they basically having a shared pair of electron with itself. Is that clear? Because we know that carbon has,
Yeah.
four electron in its outermost shell. It is going to make four bonds, four sigma bonds, one with this hydrogen, one with this hydrogen, one with this hydrogen, and one with this carbon. Now, what happens uh, when this radical comes near to this place? When it comes near to this place, this bond has been going to break. Why it has been breaking? Because we know carbon is being more electronegative, so it is going to pull this electron more towards itself, and now this bond is going to break. This bond is going to break. And we know H dot is like this. H is having one electron with itself, and chlorine is also having one electron here. So they are going to make a bond together, and they are going to make HCl like this, which is a normal molecule. This is a normal molecule.
Okay.
Yes. And now what happens? You can see that there is a electron, unpaired electron here that is present, and that is going to be come here like this. So this has been become a radical, free radical. Is that clear, Sultan, now?
Yes.
Okay. So now what happens further? Now we have this free radical. This is free radical. And now it is going to make a bond with another chlorine. Okay. Now, what it is going to do? Now, again, there is homolytic fission that has been taken place. Again, there is an homolytic fission that has been going to take place, and this bond will break. And when this bond will break, then we have, when it would break, then we know it would form free radical like this. Okay. So this bond will be break, and they are going to make these free radicals. One free radical is going to combine with this one. How? They are going to make a bond like this. Okay. This would be Cl like this. Is that clear? And there would be one radical that would be remaining like this. Is that clear, Sultan?
Yes.
So this free radical here that has been forming this normal molecule, and with the breaking of this as homolytic fission, there'll be two chlorine radicals would form. One radical would go here and would make a bond with this radical, and the other would exist as this free radical. So this is basically, you can say, the second step of propagation, and the first step of propagation would be this one. Okay? Okay.
Okay.
So let's move further. And now there is a last step which we call it as a termination reaction. This is last step. In this, now what happens? Free radicals are going to combine. free radicals will combine. How free radicals are going to combine? Like, for example, we have this free radical. This will combine with this one and would be forming Cl2. Okay. And now
Okay.
we are going to have, this radical would be there as well. So it is going to combine with Cl dot plus C dash C H H H H and this H with a radical here. So they will also combine and would be forming Cl dash C H H then C H H and then this H. Okay. So this is first one, this is second one, and there are radicals. This radical will combine with another one like this. And what happens? Like we have C dash H, 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 and this C here with H here, and they are going to combine with another same radical like this. Okay, so they are going to make a bond like this, and now this would become, now we have four hydrogen like this, and they are going to form the structure. So this is the structure that is going to be formed. So these are three steps which are related to termination reactions in which free radicals will combine with each other.
Okay.
So there are some reactions which have been related. There are some past paper questions which has been related to alkanes, and we are going to solve them in this class. So let's have some discussions related to them. So let me just open this sniping tool. Okay. Use a series of equation to describe the mechanism of this reaction, including the names of each states and indication of how butane can be produced as a minor product. First of all, let's complete this question because it's not. Yes, so this is the reaction that I'm going to describe you at this moment as well. Like, let me just take the complete picture of this. Yes, now that's fine. Okay, so first question, we are not going to do it right now. State the condition needed for this reaction to occur. Yes, what is the main condition for this reaction to occur? Yes, tell me.
UV light needs to be present.
Yes, UV light needs to be present because it provides sufficient energy for bonds to break. Okay? And now
Okay.
use a series of equations to describe the mechanism of this reaction, including the name of each stage and indication of how butane can be produced as a minor product. So, first of all, this is the reaction, and we have to describe it. First of all, we are going to write about initiation. In initiation reaction, we have to show that chlorine is going to break, like they are going to make free radical like this, and we know that would be a homolytic fission, and that occurs under the presence of UV light. Then we are going to have propagation reaction, and in propagation reaction we have to show that this molecule, okay, is going to react with this free radical and would be forming HCl with the free radical, and that would be C dot dash C H H H H and H. Okay. So, and afterwards, what happens? This molecule would again react with this free radical, would again react with another chlorine molecule. And what happens again? Hydrolytic fission has been taken place, and there is a production of free radical of this chlorine. And now this molecule would become like this. So we have to show them each and every step like this. Then moving further towards termination. And in termination, we have to show them like Cl dot reacts with Cl dot, would be forming Cl2. And then this free radical, like Cl, free radical is going to combine with this carbon, hydrogen, the dot here, and it is going to combine like this. ठीक है?
Okay.
And in the last one, they have told us how butane can be formed as a minor byproduct. So how butane can be formed when when to this radical, when to these radicals, they are going to combine, we know they are going to form the butane. Is that clear? So when
Yeah.
they are going to combine, so they are going to form a free radical like this. Okay? So they are going to form a free radical like this. Or the molecule which is butane. Okay? So this is how a butane would actually form. ठीक हो गया बेटे?
Yes.
Yes, so this is how basically this butane molecule would form. So we have to explain this for 5 marks question. So let's move further
Okay.
and let's see some more questions. Okay, so this is basically a question which we are going to do after we will do halogen alkane. And let's come towards this question. This question seems to be important as well. Let's do this whole question. Yes. Okay, so haptene is an undesirable component of petrol as it burns explosively causing knocking in an engine. There are three structural isomers with the formula on two of which contains chiral center. So explain the meanings of term structural isomer. Yes, what do you mean by structural isomer?
They have the same molecule.
Okay, so explain the meanings of term structural isomer. Yes, what do you mean by structural isomer?
Same molecular formula, different structural formula.
Yes, so compound having same molecular formula but different structural formula. Now, what do you mean by chiral?
Um, the chiral carbon
Yes,
should be bonded to four different functional groups or four different atoms.
very good. So the carbon that is bonded to four different functional group or atoms. Give the structure and names of two structural isomers of C7H16 which contains a chiral center. Okay, so we have to draw two structural isomer for that. And how we are going to do that? We know that there are basically 7 carbons, but we are going to draw 6 carbons and instead seventh carbon would be placed at branched in this way, like CC. Okay, 1, 2, 3, 4, 5, and 6, and we can place one methyl group here, and the remaining hydrogen would remain same. Okay, in this way, in this way. So you can count the number of atoms. The carbon is 1, 2, 3, 4, 5, 6, 7. So this is C7, and hydrogen is 1, 2, 3, 4, 5, and 8, 9, 10, 11, 12, 13, 14, 15, 16. So hydrogen is 16. And now, which is chiral here? This one is chiral. Okay, why it's chiral? Because hydrogen is there, which is different. Okay, you can see that hydrogen is different, methyl group is different, this whole group is also different, and this whole group is also different. So you can see that this has become an isomer. They want us to draw an other isomer. So how we are going to do that? And now we are going to make uh, five carbons. One, two, three, four, and five. Methyl group comes here. Another methyl group comes here. And now it becomes like hydrogen, 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 and hydrogen. And the chiral one is this. Is that clear, Sultan? So these are basically
Yes.
two isomers. Write an equation for the complete combustion of heptane. If we are going to do that, heptane is C7H16, and they are asking us to do complete combustion, so oxygen would be there. And we know that for complete combustion, in excess of oxygen, they are going to produce carbon dioxide and water. So we now we can balance it. There are seven carbon on left hand side, so we are going to put seven here. And how many hydrogens are there? So there are 16 hydrogen. We are going to put eight here. Okay, so now let's balance it. 7 twos are 14. 14 plus 8 oxygen, that would become 22. And we are going to put 11 here. Write an equation for it incomplete combustion of heptane leading to the production of a solid pollutant, of a solid pollutant. So in this way, what we are going to do, C7H16, and it is going to react with oxygen. Now, I have told you there might be some possibilities. Either it is going to produce carbon monoxide plus carbon plus water, either it is going to produce carbon plus water, either it is going to produce only carbon monoxide plus water. But in the question, they have told us that how the solute pollutant would be produced. So in that condition, we are going to use this equation. So that would become, because we know carbon would be in solid state. So it is going to produce water like this. And in order to balance it, we are going to put 7 here, and for a hydrogen we are going to put 8 here, and for in order to balance oxygen we are going to put 4 here. Is that clear, beta?
Yes.
Incomplete combustion can also lead to emission of unburnt hydrocarbon. State one environmental consequences of this. So you can say that either smog would be produced, or either you can write that due to this, the global warming can be produced. Okay, because of the incomplete combustion, there would be the smoke that would produce. Smoke is the mixture of smoke and fog. Okay,
Okay.
so now let's move towards the next part, and let's see. What is the next question here? Okay, we have done this one. So this is the same question that we have already done it, that UV light would be needed. Then the mechanism of the reaction between heptane and chlorine. But what is the mechanism for that? Yes, what is the mechanism for that?
Is it cracking?
No, this
Oh, no,
whole
wait.
reaction, we have just studied it, that we call this as
Free radical substitution.
shabash. We call this as free radical substitution. Okay, like we can do it later. Okay, and next one would be the same. And now let's move further towards this question. This is a very important question. So, crude oil is a mixture of hydrocarbons and provides many useful chemicals when processed. Two of the stages involved in the process of crude oil are fractional distillation and cracking. The diagram is basically shown. What has to be done to the crude oil before it enters the column? So, first we have to, you can say, boil it or heat it. We have to boil or heat the crude oil before entering this column. What trends in structure is there from fraction A to fraction F? First of all, just remember this thing, that as we are going down the group, the less denser products are at the top and more denser at the bottom. So less denser at top and more denser at bottom. Okay, more denser fraction would be collected at bottom, and they would be less viscous, and they would be having low boiling point, or you can even write that they are the small chain hydrocarbons. Okay, they are small chain hydrocarbon, and here they would become more viscous, even high boiling point, and they would be having long chain hydrocarbons. ठीक है बेटा?
Okay.
So what trends in structures there from A to